All right, on the second one there, this is what, where people try to trick you with those positives and negatives. When the negative is out in front like this with no parentheses, what that wants you to do is evaluate what you have and then make it a negative. So we do 81 to the 1/4 power, which is the 4th root of 81 to the 1st, which is 3. And then we bring that negative down.
Okay.
Oh, I wrote a 3 again. Dummy. The smart board is making me angry. Alright. Now on the next one over there, they put the negative inside the parentheses with the 81. So that means it wants the 1/4 power of negative 81. So you're taking the 4th root of a negative. What's the 4th root of a negative? It's not real. Very good. So this one, because that negative's in the parentheses, is not real. You're not real. Let's talk about it. I like that.
Those are so real. Like I feel like
Let's talk about it.
They probably are real. I don't know.
No, I mean like
The tacos.
they're not real in real life. That didn't make sense. I mean like you can eat his method.
But Shelby's talking about going over and pulling one off the shirt and eating it.
That's what it
That's
looks
about
like.
the stupidest thing I've ever
Oh, I bet they probably like took pictures of real tacos and
Genius.
pasted them on.
It's not hard.
What?
How do you do
Dad, look over there. Whatever
That does sound pretty good right now, though. I'm fully.
Okay, on these, I've got 5 new ones up there for you. The deal on these, the first few that we did, the power was 1 on all of them. When we did the power over root, it all had a 1 on the numerator. This time I put 2's and 3's up there, so it's not a 1 anymore. Okay, so 25 to the 3/2 power, you can do that on your calculator. I'm going to do it without. Power, so 25 to the 3rd over root, take the square root. Okay, now 25 to the 3rd, I'm not real sure about that. I don't know what 25 times 25 times 25 is, but I do know what the square root of 25 is, right? So I'm going to do the square root of 25 first, that's 5, and now I can figure out 5 to the 3rd. 5 times 5 is 25, 25 times 5 is 125. So that would get us 125. I did the square root of 25 and got 5, and then I did the 3rd power.
Instead of doing the 3rd power, because that's more numbers.
So that goes back to what I was saying earlier. Which one do you do first?
What happens if you just put that in the calculator?
Work smarter,
It'll
not
give you the
harder.
125.
Work smarter, not harder.
All right, so 27 to the 2/3. That's 27 squared, because power, and then the cube root. Power over root, power over root. I don't know what 27 times 27 is, but I do know what the cube root of 27 is. What times itself 3 times is 27? 3, so I'm looking at 3 squared, which is 9. On the 3rd one there, that's a power over root. The root is 2, so it's an even root, which means I can't have a negative underneath the radical. But does that negative, is it going to go underneath the radical? No, because it's just stuck out in front. So I'm going to do 16 to the 3rd. I'm going to take the square root of it, power over root, And then I'm going to make my answer negative. So the square root of 16 is 4. 4 cubed is 4 times 4 times 4?
Oh, that is
4 times 4 is 16.
64, and then I make it negative. Alright, this fourth one down here, negative 64 to the 2/3. That negative is in with the 64, so it will have to go underneath the radical. Is that okay on this problem?
Yes.
Yes, because I'm doing the third root, and that's an odd. You can have a negative when it's an odd root. So I'm going to have negative 64 squared, and I'm taking the cube root.
so 4 squared, 16.
Okay, negative 64. The cube root of negative 64 is negative 4. And then when you square negative 4, that's 16. Austin, that's correct.
Square root of 64 is 4.
No, the cube root.
Oh.
I don't think those Scooter.
I'm going to have trouble remembering all 4 of them. That's why.
Odds and evens. Go down for odds.
Alright, what about that last one? Valentina's right, Leah's right. Come on. I'm doing a square root. That's an even number. Means I can't have a negative underneath the radical. So that one would be not real. Alright, we good on that?
Good now.
Good.
I don't know.
Alright, this time on these three, we still have rational exponents. They're still written as fractions, but they're all negatives.
Not real.
No, you can have a negative
But
power.
the first one is not real. Right?
They're going to be decimals.
Okay, negative exponents, we did those last year before Christmas. When we have a negative exponent, we put it on bottom and make it positive. Remember that? Need to. So this is going to be the same as 1 over 81 to the 3/4.
Yeah.
Now,
Decimal.
I don't really, I mean, it's going to be 1 divided by something, so it's going to be a fraction or a decimal. So we got to deal with this 81 to the 3/4 down here. Power over root, so I need 81 to the 3rd and the 4th root of that. Here's 3 is 9, here's 3 is 27, here's 3 is 81. So the 4th root of 81 is 3.
I believe so.
So then I got to do 3 cubed,
27.
27.
One
And
over
remember,
27.
that's all under 1. Right? So that would be 1 over 27. So if you just do that in your calculator, and y'all probably need to be trying some of these in your calculator since that's probably how you want to do it on the test. 81 to the negative 3/4, and then if it gives you a decimal, hit math, enter, and change it to a fraction.
27.
Next one.
Is that what you got? Oh, we did.
Or you just go ahead and put it over 1 over. No, no, you use it as one, gives you the fraction.
That's good. I didn't think of doing it that way. Alright, so 36 to the negative 3/2. That's going to be 1 over 36 to the 3/2.
1 over 36.
Now that's power over root. So that's going to be 1 over 36 to the 3rd and take the square root. Square root of 36 is 6. 6 to the third. 6 times 6 is 36 times 6, I think, is 216.
Right.
So that one would be 1 over 216. All right, now the thing that's different about that last one there is it's already started off as a fraction. The first two started off as whole numbers, but the last one's already started off as a fraction. So up here, we just put it underneath 1. We can't put 1 over 64 over 25. That makes no sense at all. When it's already a fraction, you take the reciprocal of it. So this is going to be 25 over 64 to the 3/2. Okay, now remember to simplify this and make your work easier, that 3/2, that's got to go to the top and the bottom. We didn't have to write that up here because it's 1, and when you work with a 1, it stays 1. So I got to do 25 to the third in the square root, and 64 to the third in the square root. So square root of 25 is 5. 5 cubed is 125. Square root of 64 is 8.
512.
Good, because I didn't know that one. 8 cubed is 512.
And the calculator, all you're going to do is just plug it in.
Look,
Good.
this one in.
That'll do it for you.
Yep.
What you did?
Thanks, you're smart. Everybody does it. Quite good. Probably good. No, the thing's not that old.
Alright, let's go back and forth, rewriting them here. I've got 19 to the 1/2. I got 11 to the 3/4. I've got 14x to the 2/3. Alright, directions for these three say to write each exponential as a radical. Okay, they're considered exponential now because they got an exponent on them. That's deep. Write each exponential as a radical. So it wants us to get rid of the exponent and write it in radical form. Radical just means that square root symbol. So what? This is power over root. So what did I say? What's 1/2 power the same as?
Square.
Square root. So we would just write square root of 19. Just writing it as a radical. So what would this one be?
No.
To the third.
4 to the 4.
Fourth root.
Right?
Right.
Alright, now on this next one, it's the tricky one. That 2/3, is it on the 14, is it on the X, or is it on both? It's just on the X. Okay, the 14 doesn't have anything to do with the 2/3. It would have to be in a parentheses for them both to get the 2/3. So the 14 is going to go out in front. Power over root.
Because the 2/3 only on that. Right?
Mm-hmm. The book answer puts that in a parentheses, so that way you don't get mixed up and think the 3 goes with the 14, you know. Alright, we got a few more. Doing good. Hang in there.
I hope Rodney's okay.
They said he had surgery.
Oh, yeah. I didn't call him check on him.
Alright, Alright, we'll do these two first. What we're looking at here, it's a review over your exponent rules. So on that first one there, you've got 3 to the 1/2 times 3 to the 1/3. When you're multiplying with same base, and our base on number 1 there is 3 on both of them, right? You got 3 and 3. When you're multiplying with same base, you take that base, and then what happens to your exponents? Who remembers that?
Add.
Very good. So I got 1/2 plus 1/3. Okay? You can do that in your calculator. I know that 1/2 is the same as 3 sixes, and 1/3 is 2 sixes. So that would be 5 sixes, right?
5, 6. Right.
Let me see if Alright, this one with division with same base, you take that base. What do you do with your powers there? Subtract. Very good. So 2/3, this one's already got a common denominator. 2/3 minus 4/3 is negative 2/3. Okay, but now we're back into another dilemma. You can't have a negative power. So when we got that negative power like we did just a little bit ago, put it on bottom and make it positive. Now, I'm going to stop there, because if I go and rewrite that in power over roots, I'm going to have a dilemma, because 7 is not a perfect cube root, and then you're not allowed to leave a radical on bottom, and you'd have a lot more work to do. So, stop it.
Just leave it like that.
Yep. Yeah, I got a few more. This one says A to the 1/3, B to the 2/3 over B, and that's all to the 6th power. Alright, now, so what we've got, stuff that's got powers, and then we got another power. So this is what I call the power to a power. This 6, this power that's outside the parentheses, has to go to everything. What do you do when it's power to a power? We added on multiplication, we subtracted on division. What do we do when it's power to a power?
Multiply.
Multiply is exactamundo. So I got on this A here, I've got 1/3 times 6, which is 2. On this B here, I've got 2/3 times 6, which is 4. On this B down here, I've got 1 times 6, which is 6. Now, can you do anything else to that?
Yeah, but then you got to do a lot more work.
Well, but we got to simplify it, though. On the B's, can't you simplify that? So 4 minus 6 is negative 2, because it's division. And since it's a negative,
Put it on top.
put it on bottom.
It was on top. Just take the bottom. 4 plus.
Why is it
Well, did you get to here?
Yeah.
So then we did the B's, it's division, so we subtracted 4 minus 6 is negative 2. So since it's a negative, it went on bottom and it's positive.
Okay.
So if you look, and that's a good point that Bailey brings us to. If we look at it old school, if on the top I had B to the 4th, that'd be B times B times B times B. If on the bottom, you'll be quiet, I had B to the 6th. 1, 2, 3, 4, 5, 6. When you start your ninja there, where are the 2 left? On the bottom. So that's how that works out mathematically. Those last couple of B's kind of like, I don't know what, kind of with a tail. Alright, y'all remember all those exponent rules pretty good?
Yes.
kind of thing.
All right. Tomorrow's stuff gets into simplifying all these, breaking them down when they're not perfect squares, breaking them apart, and all that kind of stuff. Read up.